Hi everyone, I'm Cheryl. In this problem, we're going to be finding when the function x minus 2 sine of x is increasing, decreasing, where the relative extrema are, and then we're going to confirm our results by using a graphing utility. So let's begin by finding when the function is increasing and decreasing. In order to do this, we need to find the critical numbers, which means we need the derivative. So the derivative of my function f is going to be 1 minus 2 times the cosine of x. Remember that critical numbers happen when the derivative is 0 or when it does not exist. So let's see, when is the derivative equal to 0? And then we'll ask ourselves, when does the derivative not exist? Well, the derivative equals 0 when 1 minus 2 times the cosine of x equals 0. This is a trig equation that we can solve by, first of all, adding 2 cosine x to both sides, and then dividing both sides by 2. So we have the cosine of x equals 1/2. Now there are many different angles in which the cosine of x equals 1/2. But remember, in this problem, we're only interested in answers between 0 and 2 pi. So the cosine of x equals 1/2 when x is pi over 3, which is a first quadrant angle, and 5 pi over 3, which is in the fourth quadrant. All right, so I have two critical numbers. Next, I have to consider, when does that derivative not exist? Well, 1 minus 2 cosine of x will always exist, so this never happens. All right, so I have my critical numbers. What I'm going to do now is put these critical numbers, split my interval up according to those 2 points. And I'm going to go ahead and put this in a table to help me organize my information. So remember, I'm starting at 0. I'm not interested in what happens before 0. So I'll look at the interval from 0 to pi over 3. Then I'll look at the interval from pi over 3 to 5 pi over 3. And then from 5 pi over 3 to 2 pi, again, because I'm not interested in what happens beyond 2 pi. So 5 pi over 3 to 2 pi. Okay, now on each of these intervals, I need to determine when the derivative is positive and negative, because that will tell me when it's increasing or decreasing. So what I'm going to do is take a test point in each of those intervals. So it can be any point that I want between 0 and pi over 3. A nice point to use might be pi over 6. So let's try pi over 6. I'm going to take pi over 6 and I'm going to plug it into the derivative. All right, so this will be 1 minus 2 times the cosine of pi over 6. All right. The cosine of pi over 6 is the square root of 3 over 2. 2 times square root of 3 over 2 is just root 3. And 1 minus root 3, you don't have to do the calculation. You just have to recognize that that's a negative number. So the sign is negative. My conclusion then is that my function will be decreasing on this interval. All right, now I have to do exactly the same thing for my other two intervals. So let's take a test point, something between pi over 3 and 5 pi over 3. Now because pi over 3 is in the first quadrant and 5 pi over 3 isn't until the fourth quadrant, we have a lot of good choices. Let's just try pi over 2. Remember, you can use anything between pi over 3 and 5 pi over 3. All right, so I'll plug this in to the derivative. The cosine of pi over 2, that's going to be 0. And 2 times 0 is 0. 1 minus 0, a positive number. Again, don't worry too much about the calculation. You just need to know whether it's positive or negative. All right, if the sign is positive, that means my function is increasing. One more time for my last interval. I need to pick something between 5 pi over 3 and 2 pi. Again, any point between those two angles will work. Let's try 11 pi over 6. Okay, the cosine of 11 pi over 6 is square root of 3 over 2. Multiplied by 2, I get root 3 again. And 1 minus root 3 is a negative number. Because the sign is negative, that means my conclusion is that the function will be decreasing on that interval. Okay, I have my chart all filled out. I can start making some conclusions. I want to know when is f, we'll say f is increasing on what interval? Well, it looks like the interval that it's increasing is pi over 3 to 5 pi over 3. F is decreasing on what intervals? Well, it's decreasing from 0 to pi over 3 and on the interval 5 pi over 3 to 2 pi. Okay, next I want to talk about relative extrema. Right? So when do the relative extrema happen? Well, if you think about it, this graph is decreasing and then all of a sudden it starts to increase again. If you think about that picture in your head, you can see that there will be a relative minimum at that changing point. So f has a relative minimum when x is pi over 3. Because that's where it changes from decreasing to increasing. Well, at 5 pi over 3, my graph changes from increasing to decreasing. That's going to create a relative maximum. So we'll say f has a relative maximum when x equals 5 pi over 3. Okay, the last step to this problem is to use a graphing utility to verify our results. So you're going to want to enter x minus 2 times the sine of x into your calculator and graph. Now, in this particular problem, because it's a trig equation, using a trig zoom would be a good idea. However, because I'm only interested in the interval between 0 and 2 pi, you may want to change the windows so that the x scale is going, or that the x coordinates are going from 0 to 2 pi, with the x scale of pi over 2 would be appropriate. And for the y values, going from -3 to 10 is good for this particular graph. But as you can see, the graph that's pictured on your utility increases from pi over 3 to 5 pi over 3, decreases from 0 to pi over 3 and 5 pi over 3 to 2 pi, and has its relative minimum and maximum exactly where we discovered. I hope that was helpful. Thanks.